Alright guys, hey, it's Miss Scott here to talk to you today about the difference between mass and weight, how to calculate both of those, how to use one to find the other. Okay, let's get started with the definitions. How are mass and weight really different? And then you've probably gone through most of your lives thinking that mass and weight, they're kind of the same thing. They're really not. So, what do we have? We have mass. Mass is the amount of matter within an object. So you have mass, I have mass, Mr. Scott has mass. We are all made out of a certain amount of matter that makes up your being and my being, and this house around me has mass. Wherever you go, mass, regardless of where you are in the universe, mass remains constant. That is, unless, of course, you change the object itself. If you were to go on a diet or eat everything, you would change the amount of matter within you, thus your mass would change, but it's not going to change just based on where you are. So mass remains constant. Alright. Now, how is this different from weight? That's a great question. Oh, and I should say, mass is always, for our purposes, is always measured in kilograms, kg, kilograms. So you need to remember that. Weight, we define weight as the force of our friend gravity, the force of gravity on mass. So it has, these two things are interrelated and depend on one another, but they're not the same. So, how do I tell what my weight is? If I have my mass, or if I have my weight, how do I know what my mass is? And for our purposes, ladies and gentlemen, for our purposes, weight is measured in this standard unit called newtons. It's what we measure all force in, not pounds, not kilograms, not stones, or whatever, wherever you're from, I don't know, I don't particularly care right now. Newtons. Weight is in newtons. If I ask you for the weight, give it to me in newtons. Do not give it to me in pounds or anything else. I will say that's wrong. I will say I did all that work, but you will still be wrong. So, how do I find these magical numbers? How do I know what is my weight? What is my mass? I don't know. Well, we can find either these variables using one formula. Fg equals m times g. And it is really just that simple. Fg, of course, is that big F denotes force, little g gravity, force of gravity. Oh, that's the same thing as weight. Weight equals m. Why is my easel sliding? I don't know. Whatever. M, of course, is mass. Always measured in kilograms. And G is what we refer to as the gravitational field. I call it the acceleration due to gravity. That's the number we're going to use. Acceleration caused by gravity. On Earth, the number we're going to substitute is 9.8. That's the number I use in my class. I don't know if you're watching from another class. Your teacher might approximate to 10 meters per second squared. It's really the same thing. It just makes calculating a little bit easier. I'm going to use 9.8 because it's more accurate. Alright, meters per second squared, of course, and my weight in newtons. Alright, so let's go ahead and practice. I don't know why this is. Okay, that's better, I think. So let's go ahead and practice using this formula. F equals m times g. I'm going to leave it up here. Say I want to find the weight. Stop laughing. Say I want to find the weight of an object that has, let's do an easy one. 10 kilograms. An object that is 10 kilograms of mass. How much does it weigh on Earth? How much is the weight on Earth? You might say that's really easy. But let's go ahead and put it in our formula anyway. When you're reading these problems, circle what you want. I want the weight. I do not know what the weight is. I have this number right here, 10 kg. I know kg, that must equal mass. Erase that. 10 kg. And g is gravity. I know I'm here on Earth. If you're in any introductory physics, you should, hopefully by this point in time, know that acceleration due to gravity on Earth is indeed approximately 10 or 9.8 meters per second squared. You just multiply those numbers, and that's all you have. So I know my Fg, therefore, of this 10 kilogram mass must be 98 newtons. That's pretty easy. That's pretty easy. But what if we want to do something slightly different? Let's say, ladies and gentlemen, I have an object. And it weighs, let's say, 50 newtons. Let me get my calculator out for this one because I honestly don't know the answer. So let's say I have an object and it weighs 50 newtons. Now where is this object? It's not on Earth. I'm going to say it's on the moon. I went to the moon and I have this thing and it weighs 50 newtons. I want to know how much stuff it's made of. I want to know the mass. So I'm going to write down my information. So 50 Newton weight on the moon. The moon has 1/6 the gravity of Earth. So if you just want to divide 9.8 by 6, the answer, if you want to solve for it, I have to know it off the top of my head, is 1.63 meters per second squared. On the moon you have less gravity, so this thing is going to weigh less than it would on Earth. Pretty intuitive. No big deal. Alright, what is mass? So, I want to find the mass. I'm going to put my formula. Fg equals mg. I don't know what mass is yet. Alright, so I have 50 newtons. Anything that a number is probably important. So you're going to want to look at that. I see newtons. I know that is newtons of the force. That means it's the weight. I'm going to plug that into Fg. 50. Gravity. As told, this thing is on the moon. And you would have some way of knowing what that is. In my class, I'm going to either tell you what it is or give you some hint as to how to find it. But it is 1.63 meters per second squared. Here we just use algebra to get this m by itself. If I'm multiplying on this side, in order to get rid of that 1.63, I'm going to divide both sides. Whatever you do to one side, you have to do to both. So, 50 divided by 1.63, I'm going to give you an awkward pause while I get my calculator out. Awkward pause. And the answer oh, digger, that's not the answer. 50 divided by 1.63 gives me a grand total of 30. And technically I should do 2 sig figs because they only have 2 here, but actually I only technically have 1, but I don't worry about it. I'm going to do 3 sig figs. I'll tell you what you need to do in class. But I'm going to round my answer to 30.7. My unknown was mass, which means I need to also put my kilograms here. This thing is 30.7 kilograms worth of stuff, basically. And that equals m. So we'll do one more. Let's say my vacation on the moon ended and I have to go back home and go back to work. And I take this mass with me. I want to know how's the weight going to change. The weight is dependent on where you are in the universe, based on how strong your gravitational field is. So, let me erase this. So, I'm going to add that, what is the weight on Earth? Alright, so we found what the mass is, 30.7 kilograms. That's not going to change. Unless I actually change what this object is, like I cut it in half or I put more stuff on it, it's not going to change the mass. So my m, Fg equals m times g. I'm going to put 30.7 there. Now, I know I'm here back on Earth. That means my gravitational field is going to change. It is no longer 1.63. It's back to our good friend 9.8 meters per second squared. And from there, ladies and gentlemen, you just solve that by multiplying. So again, awkward pause, like give you a chance to solve that. 30.7 times 9.8 gives you a grand total 300. Let's do point to the nearest tenth. 300.9 newtons. That's the force of gravity, or aka the weight here on Earth. So, if you have any questions about how I did any of these problems, please comment in the section below. Our next video is going to deal with how do we take not only the force of gravity, but other forces, how do we apply it to Newton's second law of motion. So, see you then.